Okay, if we review the exercise with a different optic, now we can notice that we have two different sources of data. On one hand, we have estimates of the cost, either the price for supplying it or the cost of installation, and the annual maintenance cost of the element, and the expected life of the equipment. Obviously, there may be some uncertainties about this, the actual values that will exist for this product, but this is the information we have for the moment. But there is another component of the model that has been heavily conditioned the result. We have based all the analysis on a 6% rate of discount. This represents an attitude of the investor towards the element involved. We now know that this is the perception of the financial cost that has to be established in order to cover the results, or possibly the attitude towards investment for this company. This is a cultural issue, possibly, or possibly a decision taken by the company. But now let's open a new discussion. What happens if this 6% rate of discount is not is not representative of the situation? Okay, what happens if we were now to check if the result obtained here is stable, if there are some differences on the rate of discount? For this purpose, we can come here and just develop a sensitivity plot. Okay, for this purpose, we will write this expression. Remind that this TM uh, label or prefix has to be substituted if you are using the conventional WX maxima. Okay, but the expression is totally the same. And here we're gonna represent all these functions we have here. Okay, the first one is this one. Okay, and the only thing we do is that we alter this value, we eliminate this value, and we introduce an R. Okay, then we select the second model. Okay, and again we transform the 6% into a variable R. And finally, the third one we have already computed is this one. Okay, and it is here. Okay, so now we're going to plot this expression for a rank of R between 0 and 0.25. Okay, then we're going to introduce the grid so that we can easily measure, and okay, we'll later on write something about the title and so on. Okay, okay, there is the plot. Oh, there's some problem here that we didn't transform the rate of discount of the third case. Okay, now this is the graph. To be clear, I will add the legend. And I will take the names of the solutions from the table, mean shingles. For the first one, max singles for the second, and metal roofing for the third one. Okay. Okay, I will just write it. It's not so problematic. Metal roof for the third one. Okay. Oh, there is the bracket is missing here. And here we have the result. What we can see here is that now the situation may dramatically change. Somewhere below, close to 5, we will check what the value is. There is a connection between present worth of, annual expected unit for annual cost for case green, that is metal roof, and red solution, that is max singles. So for rate of discount below 5%, metal roofs is competitive. This is the area of competition for metal roofs. Somewhere between 5% and possibly 11 plus 12, possibly. We will be more precise after all. This is the area, the range of rate of discount where max singles are competitive. And for any rate of discount above 12, 11, the competitive solution is min singles. So this solution we have obtained here corresponds to the situation with a 6% rate of discount. That means we are checking here. We are in the area where the red solution is adequate, the max singles is the solution, is the candidate. But move it back towards 4 or push it forward above 11 and the solution may change. Okay, to be more precise on the result, I will just move around. Obtain the plot and we'll see, okay, 65, 67 possibly. Okay, 6.7 is the limit for this case. And somewhere between 11 oh, just below 11. Okay, close to 10.95. We observe the limit. Okay, so now we can add here 0, 0.45, 0, the range of R that makes this competitive. The first case, the first one is the green line, is 0. Third case, sorry, 0.0 to 4.6. After that, we switch into second candidate until 11 or 10.95. Okay, so just to coordinate the result, I will now switch this result. I will call blue the first one. I will call red the second one, and I will call green the third one. Okay, and now they're coordinated. This is the proposed solution for different ranks of R. This is dramatically different than just testing the project with a given rate of discount. This is analyzing under which political conditions for the company this solution is good. And this is somehow connecting your project with the global policy of the company. And that's important. We call this sensitivity analysis, and we will dedicate plenty of time from now on to this process. Okay?